So we'll call it, that's,
All right.
you're
So
not.
what were we talking about? Classes. Ah, yes. We were talking about apples and classes and metaphysics. So, so apples are a type of fruit, right? You could shorten this to say apples are fruit, right? Apples have seeds, right? So the thing we think of as an apple is not it's not a simple entity, right? Everything that we think of is composed of parts. The further scientists look down into the substrata of matter, the more little bits and bobs whirling around that we find, right? Apples are composed of parts. You have the skin, you have the flesh, you have the seeds, you have the scabs, right? So, at a certain point, you take a definition and to actually, provide a little bit of, something to operate on to class, you say, an apple has, skin, seed, perhaps an array of seeds, flesh, and stem. Optional. The presence or non-presence of the stem does not make or break the existence of it as an apple, right? Your apple in the supermarket may or may not have a stem. I would say your minimal set of things the apple needs to have to be considered an apple is probably these two. You need the seeds and you need the flesh. A peeled apple is still an apple, right? But once you've cut out the seeds, you are not talking about an apple anymore, because you've had to dissect the fruit in order to remove the flesh. You are talking about just strictly apple flesh as distinct from the seed, right? So that is composition, right? The apple is composed of different things, right? It may share these characteristics with other types of fruit, right? A blueberry has seeds, has flesh, has a skin, right? But so fruit, the category of fruit, includes in its definition the set of attributes common to all fruit, right? That's what fruit is as a category. In fact, you could say that the category of apple contains all attributes common to all varieties of apple, right? If you take Red Delicious, Macintosh, Gala, all of the different types of apples, there are some concepts shared by all of those different specific apples. That is what you collect up into the definition of an apple, right? With me? So far, so good? Okay. In programming, when you write a class, you are trying to write things according to this scheme of categorization, which I have described, which is the actual way that human beings think, right? Human beings think in categories more so than in specific objects, right? It's necessary to do so, otherwise you wouldn't be able to process things fast enough to interact with the world. A good example is these stupid things, right? when you sit down at a keyboard, right? Well, even if you look in this room, and you look at all of the individual keyboards in this room, you do not think of each one as being its own distinct object or entity. You think of it as a group of keyboards, right? And that is correct, because if you were hyper-focused on all of the individual detail of each keyboard that you encounter in your life, to the point where they exist as separate categories in your imagination, you would not be able to type anything, because you'd be too busy spending your time examining keyboards, right? Yes? What about that, sorry?
Music playing keyboard.
A music playing keyboard. Well, yes. So keyboard itself has subclasses. When I said keyboard, I of course meant the computer keyboards, but musical keyboards or instruments with keyboards, you might say, you know, the electric keyboard, that is a type of keyboard, right? Pianos also have a keyboard. Accordions are also an instrument with a keyboard, right? Organs, instrument with a keyboard, right? So you're kind of like, it depends on like how old you are, I think. Like if you look at younger and younger children, they think in broader and broader categories, right? Like to my 3-year-old, an apple is an apple, right? He doesn't really understand that there are different varieties of apple, you know? But, you know, we digress. So, when you are writing a class for a computer, you are trying to capture a general set of properties that will apply to a group of objects, right? So, an example I used in class, which I'd like to use again, involves geometry, right? It's a little bit easier if we talk about something mathematical. If somebody wants to suggest a different subject other than points and lines and that sort of thing, I'm happy to give it a shot, but I'd like it to be something a little mathematical. Geometry it is. So, if we define a point in space, say we define a point in 2-dimensional Euclidean geometry. This marker is beginning to wear a little thin. We can define the point by 2 values, an x and a y value, right? So, we are talking about a class, because point is a concept, right? Therefore a class. We know we need x and y values to describe the class. So, class point has, let's say, float x, float y, right? We have our x and y coordinates. We might have a method in here which, you know, distance to origin, public, float, distance to origin, which of course, if this is the origin, 0, 0, the distance to the origin is of course just Pythagorean theorem as applied to the 2 coordinates, right? So, return math dot square root x times x plus y times y. Fairly simple. So now we have a class that has attributes and a method. Does this make sense? Any questions? So far so good? So the question that we must ask ourselves is, what is the advantage of doing so? Right? Defining a point class allows us to work with objects of that class as variables in, a reasonably cogent way in other parts of the program. So, if, for example, I wanted to declare an object of class point, I would say point A is equal to new point. Point B is equal to new point. There we go. Let's review public versus private. All right? So, if these are public, this operation succeeds. A dot x is equal to 7, B dot y is equal to A dot x. These two operations will succeed because making them public gives us full access to the variables from outside the class. This is a context outside of the class. In Unity, this might be your start or update methods. In a C# console app, this would be like the main execution. Inside of a C# Windows Form app, this might be inside of a like a button click event or something like that, right? It's a different context from the class's declaration. Okay? Good? So far so good? Any questions? Okay? If I change these to private, this thing creates an error and this thing creates an error. You are not permitted to read or write from values which are private, not from outside the class. You can do so from inside the class. You'll notice that x and y are being read inside of this method, no error results. But from outside of the class, making those private causes these two statements to be errors. Make sense? Any questions? Do you have your hand up? Oh, okay. It's difficult sometimes with like the hands and the monitors. So if you have to raise your hand, please get it up above the level of the monitor so I can see it. So that's the idea between private and public. Functionally, that's the difference. In terms of why would you need that distinction, right? So, it's kind of like, why would you want privacy at all, right? Human beings, we like a little privacy, we depend, some people like more privacy than others. But basically, if you have set this up so that x and y cannot be modified in this manner, you set it up so that you can control how they're modified. So let's add a new method. Public void set x with double new x. Let's say, just for the sake of interest, this isn't like applicable to this scenario, but you can imagine. Let's say, just for the sake of interest, x is not permitted to be less than 0, right? Perhaps we are taking the square root of it at some point in the calculation. X can't be less than 0, or it will make the program fail, or put you in some kind of error state. We don't want it to happen ever. If we make this public, and people are just grabbing that variable and doing whatever they want with it, they could very easily decide to put it into a value that would cause an error, right? They would put like a negative value into it, not realizing that there's this problem where if you put a negative value in, it breaks the calculation, right? Therefore, they try it, it fails, you get a bug report, your boss is on your behind to get it fixed, right? If the value of x must be set through a method rather than direct access of a variable, we can control the circumstances under which it gets set. We can make decisions. We can control our data policy. So, for example, if x is less than 0, x is equal to 0, else x is equal to new x. Right? So in this case, x is not ever permitted to be less than 0. If somebody sends a value for x, which would be less than 0, right? It stops it, writes 0 instead, and then stops. But if that's not the case and the value is valid, then it writes it in. So, how that changes the code here, rather than accessing x directly, we say a dot set x to 7. This no longer causes an error, right? So this is the purpose of private and public. You are setting the code up so that a complete moron, and by that I mean probably yourself, can understand the code later, right? So the problem is, by the way, I include myself when I say that. The problem with programming, and I'm sure, I actually don't think you folks have worked on a large enough programming project yet to have experienced this. You kind of have to do a project and then come back to it in like 3 or 4 weeks, right? But there's this problem where you write code 3 weeks ago, you then, you go and you play video games for 3 weeks. All of your brain, from all the video games, your brains just kind of ooze out of your ears into a collection cup, and you collect your brain and you drill a little hole in the top of your head, put a funnel in, and then pour your brain back in, put plugs in your ears to stop, coming out again, right? Because that's how video games you were those 3 weeks. You come back to your code, and you have completely forgotten everything you were doing, right? First of all, this is the reason you want to leave comments, right? not just for other people, they're for future you. Right? Second of all, you are likely to forget all of these little conditions, right? If it's true that x should never be negative, if you just say, oh, I'll remember that x should never be negative, you won't. You will forget that, you will break your program, and then you will wonder why, and then you will spend 2 or 3 days debugging it to try to find out why, and then eventually you'll be like, oh, x should never be negative. And you will waste those days. Those will be days you will never get back. Right? You will be 3 days closer to the grave because of the fact that you didn't properly protect yourself from yourself. Right? Not to mention, your employer will not be pleased that you're spending this long doing these sorts of, stuff that's basic. So, does that make sense? So that's why you want to use private and public. Good. Minimal example of inheritance now. So, the geometry example is a little bit, like it falls apart a little bit because things aren't really, well, okay, here's one for you. So we have a point, right? Let's say we have another class in scope. Somewhat similar to Unity, class color, all right? Let's imagine that that's defined elsewhere. We don't have to define it. Let's say that we're writing points for a program that graphs something, right? We want to do points on a graph. A feature that you may wish for points on a graph is to be able to draw those points with different colors, right? So, we want to come up with a class which is a point, but it has this new color property. But we don't want to modify the original point because maybe this is also used by a geometry engine where that's not a useful distinction, right? Maybe this same class is being used to do like vertexes in a wireframe or something, right? So in such a case, we would write a new class data point, and we would inherit from the original definition of point. A data point is a type of point, right? Data point inherits from the definition of point. So what does it functionally mean in code that we are inheriting? All of these definitions, all of them, are copied and pasted here, more or less. You still have to use, like, inheritance will respect public and private. So if you're inheriting from a class, you still have to access things through its methods, if they're private, right? But float x, float y, distance to origin, and set x. Those are all definitions that will carry forward to the derived class. By the way, this is the derived class And this is the base class. Right? Point is the base class, data point is the derived class. So, what makes a data point different from a regular point? The inclusion of a color, right? Color C is equal to, oh, who knows, initialize it to color.red. Right? You can also add new methods that apply to the new data. So, for example, change color. Let's make it private. New method, public, void, color change, color n for new, C is equal to n, and method. There you go. Right? So, the data point class picks up all of this stuff. So it still has an x, it still has a y, it still has distance 2. We now add these additional definitions and we end up with a thing that is further specified. We're talking about a more specific type of thing now. That's always the way that inheritance works. The base class is always less specific and the derived class is always more specific, right? Think about fruit. Apple inherits from fruit. Fruit is a more general sort of thing. Apple is a more specific sort of thing. Right? Does that make sense? Fruit might inherit from another class, plant part, right? Which would include things like, roots, branches, leaves, rhizomes, all of the things that compose a plant, right?
We have like fall.
Yes, so, okay, let's do it. So let's imagine we have apple, right? That will inherit from fruit. Fruit inherits from plant part. So what is a general category that includes plant parts and other sorts of things? Nature? Nature is, so it doesn't make a good category for our purposes if can you think of a nature? We can think of a plant part, right? And I know this is a little bit different from how human beings work, right? But a lot of the time when people think about nature, what they're actually doing is anthropomorphizing natural processes, right? So we think about nature, we think about some sort if we see a mountain vista and we say, ooh, what pretty feature, it's like a description of the sense of awe and beauty people feel from encountering the natural in grand scale, right? But if we think about the nature of something, right, that's a different way of putting it, right? What is the nature of nature? That's often we're mapping human concepts onto natural features. But I'll back away. So plant parts, things like roots, leaves, stems, fruits. What is a general category that encompasses all of those things plus a few more things? Yeah.
Sugar-based fruits.
sugar-based fruits.
Sugar.
So sugar-based fruits, like, that would be a subcategory of fruit, right? Yeah, we're past fruit. We're now to plant parts. What's a more general thing than the plant part? Yes?
Vegetation.
Vegetation. A plant itself is is a plant part a type of plant? Yeah. So a plant part is a type of blank. In theory, for some plants, right? Like there are lots of different types of plants where like you cut a leaf off and you can grow a new plant from the leaf. But that's not a characteristic shared by all plant parts. Right? So I would say photosynthesizer is a description, like that's a property of plants. Right? Yes.
You go to super general say
So living, again,
plant.
is a leaf on its own a living thing? It's only a living thing if it's connected to a living organism, right? We've kind of picked a hard one, actually, right? So I would say the next category up is probably organ, right? So if you think about organs as being, like we typically think about organs in like the, animal sense, but a biologist would tell you that plants certainly have organs as well. If you look at like what the real definition of an organ is it's a collection of tissues that are all organized towards some purpose, right? That is a definition which fits all plant parts, plus a few things besides, right? Animal organs, fungal organs, right? You were basically at this point describing the structure of multicellular living things, right? Does that make sense? Because an apple is an organ, right? A leaf is an organ of a plant, right? A plant is not an organ of a plant, right? So here's another fun one. How do you get more general than organ? What is an organ? Tissue, so tissues compose organs. An organ is composed of tissues. A thing that's functional that does work. We might call that, well, I'd call that a system. Right? A system, right? Now we are talking about very general concepts, but if you remember the definition I gave for an organ, it's a collection of tissues, not necessarily animal, animal, plant, fungal, doesn't matter. It's a collection of tissues organized to serve some purpose. When you organize things to serve a purpose, that's the term we use for that generally is system. But you can go other places with that as well. You could call it an organization, right? But let's go with system, right? So what is a system? A system is a thing that does something, right?
Systems have parts.
Systems have parts and goals, but what's more general than a system? You actually already said it.
Organs.
Nope, that's going the wrong way. A system is a thing.
Oh my god. It's a noun.
Right. So at a certain level of abstraction, you've become so abstract that, like, you know, what is even the point of this anyway, right? But it's true, systems are a type of thing, right? Apples are all of these things, right? An apple is a fruit, an apple is a plant part, an apple is an organ, an apple is a system. Although it's weird to think of an apple as a system, an apple is a system. An apple is a system for the delivery of seeds to the earth, right? Apples are a thing, and nobody would argue that an apple is a thing. Right? So, and now for the part where I bring it back to code. Inside of object-oriented systems, you will have a base class that everything inherits from called object, typically. There will be one object class that everything inherits from by default. It's normally not stated explicitly, but when we wrote class point, inherent in that definition was the fact that it inherits object. Object provides a number of basic definitions which you may or may not want to change for your particular object. One, what does it mean to print this thing as a string? Right? That is defined in the object base class. It's probably not very useful for your, like the base definition is probably not useful for your specific thing. I'm not sure about C#, but I know in Java, the default definition of printing an object gives you the memory address at which that object is located in memory, which is doesn't really tell you about the contents of the object, but it is information about the object, right? And it can be useful information as well. But another basic definition that's provided by the object class is what does it mean for two objects to be the same, right? We have equality, like the double equal sign, defined for everything by default because object contains a definition for it. Does that make sense? Class is dismissed. Although that was somewhat rude of me. I didn't pause for questions before I dismissed the class. Are there any questions? Yes. That is because I am an arbitrary tyrant, and the sooner you learn that about me, the easier we're going to be able to get on with each other. I like to think of myself as a benevolent tyrant. It's a parenthood thing. So, are there any questions about anything we talked about today? Yes, we're going to be continuing on our discussion. We'll talk about constructors. We'll do some object examples, some more object examples. But yeah, review tomorrow as well. Okay? If you have anything you would like to have covered, please bring it for class tomorrow. I will be answering questions. You have a question?
Is there a chance you can close this video tonight?
I can get it. I can do it tomorrow. I'll tell you what I'll do. Send me an email to remind me. I'll do it tomorrow morning, and like I normally set them to be published at midnight, but I'll publish it like at noon or something as soon as it's done its processing.
So do I email you today or tomorrow?
Email me today, so that you don't forget, so that I don't forget, because I forget. Good. Any other questions? You had a question? No, it is on paper. That's not true. That's all not true. Yep. Yep. It's just going to be on paper. Trust me, you don't want to write that test. All right. The test that's described there, you don't want to write it because you want to know what those labs were before I change things to paper tests. It was, you got 2 hours. Now do this lab.
You only get 2 hours just in class.
2 hours in class, do this lab. So, do you hate the paper tests now? All right, I'm out of here. Take her easy. So, good afternoon, everybody. How's everybody doing?
Good. How about you?
I'm doing okay. There we go. So, today we are doing additional test review. So, before, we had this list of topics which we had chewed through a lot of them. Can anybody remind me where we left off?
I think inheritance, we were talking about you made a web of a plan part next to a plan, next to a system, next to.
Yes. Yeah, I think we've given inheritance a pretty good treatment at this point. So we should probably move on to other topics. Same thing with composition. So we talked about classes and objects in general. We talked about what public and private mean. We talked about inheritance, and we talked about composition. We could talk about how this applies in Unity, right? With the creation and destruction of game objects. Shall we start there? So, inside of Unity, there's only so far you can go with a program without being able to bring game objects into existence using a script and take them out of existence using a script. Now, the function names which perform these two operations are instantiate and destroy. So both of these take one argument, at least one argument, right? In the case of instantiate, you need a reference to a game object definition in order to be able to create a real instance of it, right? So we need here a game object reference. With destroy, destroy is a little bit more general. It can be used not only to destroy game objects themselves, but also components of game objects. So basically, whatever reference you hand to destroy, it will destroy that thing, right? So with destroy, a common error that people make is to throw this into destroy and imagine that they are destroying the game object. But they aren't. We are used to the idea of this as a keyword. What does this do as a keyword? Hopefully, somebody knows. Yes?
Does it reference like the class itself? This class?
Yes. So this references the class. Well, it references the object that's been made from that class, which is a slight distinction. We haven't really done much of this in Unity so far, but when you write a script in Unity, that script can be attached to more than one game object, right? So you have the script definition, which is the script class, right? But every time you attach it to a game object in Unity, you are creating an instance of that script for that game object, right? Because different scripts attached to different game objects can hold different values, right? If I have a race car object and I have a script that controls movement, one race car might have more top speed and less acceleration. The other one might have more acceleration and less top speed, right? Those are all just values, but the actual value of the values varies between these two things because they are objects, right? With me so far? So far, so good? So, so a common error that people make is to think that this refers to the game object. It, in fact, refers to the script, right? So, in Unity, the way that you destroy, the way that you have a script attached to an object which conditionally destroys that object, this dot game object is what you are destroying, right? So dot game object takes the script and it takes the script reference, this, and it pops one level up to the parent, right? The parent being the game object, and so when you destroy this .game object, you destroy the whole thing and not just the script, right? So for example, let's say that you had a script, small script, to control the movement of a bullet in a shmup, right? Shoot 'em up game. The bullet script, let's say, like, as a memory saving thing, you want any bullets that fly off screen to disappear. You want to, remove them from consideration. They're not going to hit anything interesting, right? If you write a script, let's say you're doing like a Galaga type thing. If they cross the top, if the bullets shoot up, cross the top edge of the field of play, you deallocate them. If you used this .game object, right, what you would end up with, if you have your little shooter, your bullets would all get frozen at whatever that Y level is that you decided was the threshold to destroy them, assuming that the movement of the bullets is controlled by the same script, right? Because if the movement of the bullet is controlled by the script and you destroy the script, the bullets no longer move. They stay in the place where you destroyed the script, right? So this is not what you want. Peeling the script off of them does make it so there's less processing to do, right? So it's not like you're saving no memory, but you know, it's entirely possible that physics calculations are still occurring with these things, and you want to like remove that too. So if you use this .game object, as soon as the bullet crosses that magic threshold, which would be an if statement, it would be like if y is you know, greater than 10 or something, destroy this .game object. Once it crosses that magic threshold, the game object itself is destroyed. Make sense? Good. So that's destruction. Let's now consider creation. Going with the same example, if we have our little shooter, right, inside of the Unity assets pane, we will hopefully have a little bullet, right? A little bullet prefab. We have the definition of a bullet game object, but not necessarily an actual instantiated game object, right? We feed a reference to this into instantiate. Then, when we instantiate it, we get the bullet on screen. This thing will have a default location, right, which it comes with. If it's 0, 0, 0, then it will pop into existence in like the center of your field of play, right, depending on whether or not you've moved the camera. So, in order to have the bullet start off on the ship or inside the ship or, you know, at the point of the ship or wherever you want the bullet to start off, you need to make the position of the bullet on creation relative to the position of the thing that created it, right? So, the instantiate function, instantiate bullet, the instantiate function has a return value. That return value is a reference to the newly created object, right? So we can say something like game object obj is equal to instantiate bullet. Now we can use scripting to modify the properties of the object that we just created, such as object dot transform dot position is equal to, I'm just going to close the door. Object.transform.position is equal to this dot transform dot position. So we take the newly created object, we set its position to the position of the thing that created it, this. That snaps the bullet to the game object. Its own script then takes it from there, and it travels vertically until it hits the threshold and disappears. Does that make sense? Are there any questions about that? Yes.
So just to clarify, game object obj equals instantiate bullet makes it so that the object creates a bullet.
Sorry, can you say that a little louder?
So the game object obj equals instantiate bullet pretty
Yeah.
much means that the object is creating a bullet, and then the bullet has its own script.
So the instantiate method creates an instance of the definition in the assets pane, right? Bullet is a reference to something in the assets, right? Instantiate bullet takes this and makes a copy in the game world, right? The copy that exists in the game world is the return value of that method. We are capturing that return value in a newly created variable called obj object. Type declaration, so this is the type, that's the variable name, this is a type declaration where the value we are instantiating the variable with is the return value of the instantiate method. Ugh, what a word, what a mouthful, eh? It's no wonder nobody likes programming, eh? Then, on the next line, we take that reference, obj, we can then access the properties of it like it's any other game object. This object.transform.position is equal to this.transform.position. We can modify its properties at that point in the script, but this script only executes once. You can imagine this being inside of an if statement that says, if input.keydown keycode.space, right? To have the bullet fire when you hit the space bar. So after its point of creation, the script that created it does not necessarily have to have anything to do with it, right? It has its own script. It does its own thing. The bullet's script controls the bullet moving vertically across the field of play, right? And the bullet's script controls its destruction when it goes outside of the field of play. The parent object does not have to manage the behavior of the child. The child's script controls the behavior of the child, right? So, does that explain it?
Yeah.
Okay. Any other questions? Points of clarification? Okay. Is there anything anybody wants me to cover?
Trying to remember what we had in the board yesterday.
If only somebody took a picture of it.
You mean what was in the board?
Yeah.
The last two things we needed to cover was class objects and constructors.
Say that last one a little louder.
Constructors?
Constructors, yes, that's a good one. So class object distinction is what that other one is, and we did cover it last time. So yes, let's talk about object constructors. So the way that this works in Unity, the start method executes when on the first frame that the object or that the script exists, right? Often this is the very first frame of the entire game, but if it's one of these where we've created the object, it would be the first frame during which the object exists. That's what start does, right? A constructor is a bit different. The constructor executes immediately as the object is being created. In fact, one might say the constructor creates the new object, right? Constructors do a bunch of stuff in the back end that we don't have to worry about, allocating memory for the new object, that sort of thing. All we have to worry about is keeping track of the state of the class, right? So, for example, let's pull in our ever-popular point class. Does anybody have the time?
for each item.
Cool. So, I don't see a clock in here, and I forgot my phone in my office, so just give me a holler when I'm like 5 minutes to the end of class. Let me know when class is over, okay? So class point. Private integers x and y, right? So using a constructor, we can, so from a functional perspective, if you don't supply a constructor, this is how you must create an object. Point A is equal to new point. Empty braces. If you have defined a constructor, you are allowed to put stuff in here. In fact, you might be required to put stuff in there. So if I create a constructor, public point accepting int x naught, y naught indeed, x is equal to x naught, y is equal to y naught indeed. I said it twice. Right? So this is a constructor. You can tell it's a constructor because its name is the same as its return value. Right? Normal methods would be something like, public int sum. Right? You have that type declared right there, right? In the case of a constructor, there is no type declaration because the name of the function is the same as the name of the class, which is the same as the name, or the same as the type of the return value. So the constructor returns a reference to the newly created object, in the same way that instantiate returns a reference to the newly created game object. So, if you don't specify a constructor, you get this one. You get this one for free. A constructor that takes nothing and does nothing. Right? But as soon as you have specified one, as soon as you have said, I want there to be a constructor that's not the default constructor, like this one, this becomes a syntax error. Adding a constructor to the class removes the default constructor. Because we don't have the default constructor anymore, we need to supply the arguments which are requested. Right? So we now need, instead of saying, so in the old style, you would say point A is equal to new point, A dot X is equal to 3, A dot Y is equal to 7, right? Assuming that these were public and not private. With the constructor, you simply say point B is equal to new point 3, 7. Which is much easier, much more intuitive, and it respects privacy. You can make those variables private and access them with the constructor. You can't do that here. You would have to write separate get set x and set y methods. Now, in object-oriented design, there are going to be situations where it's appropriate to be able to set values when the object is created and at no point at no time after that, right? Initial values, right? Let me see if I can think of an example of that. Take our bullet, for example, right? You may want bullet speed to be adjustable on a level-by-level basis. You could increase the difficulty of a game by increasing the bullet speed, right? But once created, the bullet should not alter its speed if it's just a simple linear bullet, right? So you set it once at the beginning, it keeps that value for the duration without modifying it. It is part of the principle of least privilege that anything somebody doesn't need to modify, doesn't need to have access to, you don't give them access to it. This is a good principle of software design. One might even say a fundamental principle of software design. So, does that make sense? That's a constructor. There are also such things as destructors. They operate the same way but in reverse. A destructor executes upon object destruction rather than upon object creation. Now, it's a little bit trickier with objects in C# as opposed to game objects in Unity with respect to destruction because of the issue of garbage collection. But we're kind of, it's kind of off topic. That would be a big digression, and don't worry, garbage collection is not on the test. So, good. Any other questions? Anything anybody wants me to discuss? Yes.
Can a constructor be anything? We used point for this example. But can it be anything? Is there a certain amount of things that can be constructors?
You can make a constructor for any class, but a class. Actually, I was about to say a class can only have one constructor, but that's not actually true. But that's like a somewhat advanced topic called polymorphism. We didn't really talk about polymorphism, so yeah. Oh, I should say one thing about the test. This time I will allow you to have a crib sheet. I don't know if I made that announcement. Did I make that announcement?
What do you mean by that? Is it
You are permitted to have one 8.5 by 11 piece of paper. You may put on that piece of paper anything you feel you might need to know during the test.
so cheat sheet.
A cheat sheet or a crib sheet, yeah, that's the same idea.
Okay.
So, if I may make a recommendation for crib sheets, make your own. Particularly, don't get the stupid chatbot to make it for you, but it's also, I know a thing that students sometimes do is it's like, oh, hey, can I use your cheat sheet? It's like, oh, let's collaborate, make the best cheat sheet between all of us. The act of making the cheat sheet is very good studying, because what you have to do is you have to sift through the material that's been covered in the course so far, decide what's important, and then summarize it on your cheat sheet, right? This is a very good way of putting things in your brain, right? So the act of making the cheat sheet itself is the best purpose of the cheat sheet. I don't even particularly care that you have it during the test. That's like my gift to you. You should make a cheat sheet even if you don't have the ability to keep it during the test. It's an excellent way to study. But, in my case, I guess, I want to make sure people make the cheat sheet so you can bring your cheat sheet with you. Okay? We sometimes call them crib sheets because little babies need them. Little babies in their cribs, but you know. Yeah, makes sense? You guys feeling maybe a little better? Yes?
I feel like it's obvious, but I want to make sure. It's just front side, right? No back side.
You can use both sides.
You use both sides?
I don't want to go through the room flipping people's cheat sheets over. It's like, oh, but I wrote that since I got here. It's like, no, you can have both sides.
So it's gonna be like half of this page, right? Half of it. Like this is page, half of it, right?
You may have one page, front and back. That's what you may have. You can write anything you like on it, except, like, the test itself. But I don't see how you would get a copy of that as, I have all of them. So, front and back, 1 8.5 by 11 piece of paper. Don't bring in a Bristol board, you know. Also, some people find it useful to create the cheat sheet on a computer in like size 2 font so they can cram as much information onto it as humanly possible. The one thing that you should keep in mind about the cheat sheet is if it's going to be useful to you during a test, you should be able to read the goddamn thing, right? If you make the print too small and you spend half the time in the test, it's like, what does that say? What does that say? Not to mention the more information you cram onto it, like it's just like an information density thing. It will take you longer to find the thing you're looking for if there's more information on it. So, like I have seen cheat sheets at the university where they have literally taken like entire slideshows of notes from in class, and they've done it so that each slide is a postage stamp, right? So no magnifying glasses. Actually, you know, I don't even think that rule would be enforceable. You can have a magnifying glass if you really want to. Just don't print your cheat sheet on like microfilm, where you need like one of those microfilm viewers like they do old newspapers on in the library. Don't do one of those, okay? So, yeah, cheat sheets. The people who aren't here should know that as well. I should make an announcement. Yeah. Any other questions?
Is it just gonna be the things we discussed about array and sensation and just those two?
So the
Adding the Windows forms, sorry to cut you off.
no, Windows forms are not on the test. The test coverage stopped when we started doing Windows forms. Basically, the coverage is from that point to the previous midterm. So arrays and all of that stuff we did up with objects. So I can't really do arrays without while loops, and you really can't do anything without if statements and stuff and such. So like while I say, you know, the coverage is since the last test, it's not cumulative. The material itself is strongly cumulative, right? Like there's not much I can do with you if you don't know what a variable is on this test. So if you require some review of topics before the test, you should do that as well. Perhaps you want to include some of that material on your cheat sheet as well, you know, how an if statement is structured, etc. That would be useful stuff to put on there as well. Because, well, let me put it this way. Looking at the results from the last test, Probably the majority of you could use a refresher on that material too. I don't want to put it too bluntly, but you know, you guys should study. It's okay. It wasn't too bad actually the last test, but you know. Yeah. Any other questions? What time is it?
3:36.
Well,
Can we do another example of constructors?
sure. We can do another example of constructors. What should the class be for?
A car.
A car? Okay. Public class car. Public is like optional, you know. It doesn't really matter for our purposes on a class, but you know.
Should we include public or private in the test, like for writing, like constructors or something?
On a class, it doesn't matter. On variables, it matters, and on methods, it matters. So let's say car has int wheels defaults to 4, float speed defaults to 0, public string honk return honk honk just for flavor, right? Now for the constructor. So in this case, let's throw this as, let's not include that there, right? Let's make a constructor which assumes that the initial speed of the car is 0, reasonably, like, actually, now that I think about it, that might not be a reasonable assumption because cars are made on an assembly line. So like at the point the car is finished and made, it's probably traveling. Its speed is non-zero, but let's simplify the universe a little bit. Public car, it will take an int w, which we will slot into the wheels, and the speed will have a default value. Wheels is equal to w, and speed is equal to 0. So now we have a constructor that takes one argument, but the thing has 2 variables in it. Does that make sense? So the way that you would use that car Chevy is equal to new car having 3 wheels. Car Ford is equal to new car having 5 wheels, etc. Actually, I think that's 6. Because you've got those trucks now that have like the double wheels on the back, so it's like 4 and 2. Three-wheeled cars also exist. I don't know if it was a Chevrolet, but you guys ever watch Mr. Bean? Yeah, you know the three-wheeled blue car from Mr. Bean? Yeah. So they do exist. Yeah. Good. Any way you would want that? Is there anything you want me to do with this?
Could you manipulate the speed as well, like in what same way you do with the wheels with the new car? Or is wheels the only argument you can take?
I'll give you one better. I'll show you a little bit of polymorphism. So you can actually define multiple constructors. They just need to take different arguments. So you could also say public car taking int w and float s sets wheels equal to w, sets speed equal to s. This way, we can say car smart is equal to new car having 4 wheels and an initial velocity of 8.3. And all of these can be in the same program. This does not cause a syntax error. If you call the constructor with one argument, you get that definition. If you call it with 2 arguments, you get that definition. Although you also have to line the types up, right? You would have a separate definition for like car int float would be a different definition than car float int. Those would need to be separately defined, right? Yeah, so you know, like in Unity, when we use a Unity method and like it does the tooltip, but there's an arrow and there are like a bunch of different definitions taking different number of arguments. That's what that is. We're just doing it with a constructor, but you can also do it with like just your general method. Yeah, like we could, so this is a type of polymorphism called overloading. So we have an overloaded definition of car. That make sense?
Yeah.
Cool.
So last test, we were allowed to use calculators, right? Is it the same for this test too, or no?
You won't need it, but if you want it as a safety blanket, then sure.
Okay.
Yeah. If your calculator is your comfort object, you may have your calculator. Yeah. Cool. Anybody else have any questions, any direction you'd like to take the conversation? No? I know I said anybody else, but I just wanted to give them a chance. You can also direct the conversation if you wish.
Any upcoming games you're excited for?
Lately I've been playing Factorio Space Age. So the one I've been waiting for came out a few weeks ago. So I'm not really looking forward to anything because I'm too much factories in space right now.
Yeah.
Yeah.
I have a friend that plays that game.
Yeah. it takes a very specific form of nerd, that game, but like if you are a person who's vulnerable to it, that game is literal crack cocaine.
Yeah.
Yeah. How about you?
Then you Ghost of Tsushima, like the sequel to Ghost of Tsushima.
I think we're